There are three different types of radioactive decay that you can look into. Alpha, beta, and gamma, and then there's transmutations. Generally, we don't deal with gamma, but you will see alpha and beta, and you will see transmutations. So the big thing is that mass must be conserved. So whatever you have on the top of both sides of the equation and the bottom has to be the same. So if you start with something like carbon, say it's carbon-14, which will over time break down into nitrogen-14. Carbon-14 is going to turn into nitrogen-14, but to do so, it's got to release a beta particle. Now, beta particle is just a fancy word for electron. We call it beta because it was the second type of radiation found. But that's all it is now. We know that. And so if you look, 14 on the left is equal to 14 plus 0 on the right, and 6 on the left is equal to 7 plus -1 on the right. So the two numbers should balance out. For any beta decay, that's always going to be true. The left side top, right side top will be the same. 14 equals 14. And same with the bottom, 6 equals 6. Okay, but you do so by removing an electron. The reason why it has that 0 there is that electrons are considered massless. They actually aren't massless. There's no such thing as a massless particle. Though gamma kind of are, but we're not getting to that. We just treat it as that because it's so much smaller than everything else. Alpha decay is very much the same. But alpha decay usually have a very large particle breaking down and releasing what's called an alpha particle. So let's say it's uranium. Uranium is massive. Uranium can break down by releasing an alpha particle into something much smaller. And so in this case, an alpha particle is just helium. We call it that because it's the first one found. So I've got 92 on the left, which is equal to 92 on the right, 90 plus 2. 238 on the left is equal to 230 on the right, 234 plus 4. So the top left and top right have to be the same. That's the trick. You just have to make sure the top, left, and right are always the same. A transmutation is basically the same exact thing, but instead you're usually merging two particles together or breaking off other particles such a result will still balance, but it's not through alpha or beta necessarily. So I'm just going to make something up at random. Let's say I have sulfur. And let's say that sulfur, we'll magically mash it with another heavy particle. Let's mash it with oxygen. So that my grand total on this side is 24, and my grand total on this is going to be 48. And let's say on the other side that we'll have a lithium break off. And we'll make it lithium-7, regular lithium. Well, this has to add up to 24. So there should be a 21 here. And the top has to add up to 48, so there should be a 41 here. And so that'd be scandium. Scandium's number 21, because there's a total of 24, and the top there's a total of 48. And so that'd be a transmutation. For transmutations, it's a little more complicated. Generally speaking, you have two particles you mash in each other with a very large particle accelerator, and then other particles come out. That's something we'll talk about more in person when we get back together. But that's it.